Hello students, this is the second part of permutations and combinations. Today I am going to explain the definition of permutation and combination and some theorems on permutations. So before that I explained about factorial notation. N factorial or factorial n means the product of first n natural numbers. So based on this n factorial we have some important property. Students should remember like this: 1 into 1 factorial plus 2 into 2 factorial plus so on plus n into n factorial equal to n plus 1 factorial minus 1. Observe verification. If n is taken as 1, so what is LHS? 1 into 1 factorial, that is 1. What is RHS? 1 plus 1, 2 factorial minus 1, that is equal to 2 minus 1, that is equal to 1. If n is taken as 2, what happened to LHS, Nana? LHS is 1 into 1 factorial plus 2 into 2 factorial. This is 1 plus 4, that is equal to 5. So what is RHS, Nana? N is taken as 2, no, 2 plus 3 factorial minus 1, that is 6 minus 1, that is equal to 5. Means what happened here? What I did here, just I verified. Now you want to prove that this result, important result, Nana. Okay, observe here LHS. What is LHS? 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial so on plus n into n factorial. We want to prove that the summation equal to n plus 1 factorial minus 1. Or I can say that this is nothing but sigma n into n factorial, where from n is taken as 1 to n. Both are give same meaning. Okay students, listen now. So how I am writing this is interesting thing. This n can be written as n plus 1 minus 1 into n factorial with sigma symbol. Okay, what I can write as sigma n plus 1 into n factorial minus n factorial. What is the meaning of that? N plus 1 factorial, n plus 1 factorial minus n factorial. Okay, so now I want to open sigma. What happened? Observe all of you. So this is same as here. What happened? N is taken as from 1 to what? N is taken 1 to n only, no? 1 is taken 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial. Sorry, 2 factorial. So n is taken as 3 now. What happened, Nana? Yeah, 4 factorial minus 3 factorial so on plus n plus 1 factorial minus n factorial. Students, observe Nana here. What happened here? This 2 factorial get cancelled. This 3 factorial get cancelled. So what happened? This n factorial and previous one n factorial will get cancelled. This 4 factorial here, 4 factorial will get cancelled. What is left with us, Nana, here? Minus 1 factorial plus n plus 1 factorial. So what I can say, this is n plus 1 factorial minus 1. Okay, I hope you people understood. So finally what happened, Nana? This is 1 into 1 factorial plus 2 factorial plus n into n factorial is nothing but n plus 1 factorial minus 1. Okay, yeah, just again I want to explain same thing, students. Listen, what I did, I want to explain again. N into n factorial. What I did in this n plus 1 minus 1 n factorial. What is that? N plus 1 into n factorial minus n factorial. What is this? This is nothing but n plus 1 factorial. N plus 1 factorial minus n factorial. So what I did, I will show you here. N plus 1 factorial minus n factorial summation. If n is taken as 1, what will get then? 2 factorial minus 1 factorial. N is taken as 2, 3 factorial minus 2 factorial. N is taken as 3, 4 factorial minus 3 factorial. So on. Just I am writing in a vertical way. Nana. So if instead of n you write n minus 1, what happened? Nana? N minus 1. N factorial minus n minus 1 factorial. So instead of n you write n, what happened? N factorial minus n factorial. Just we want to add all these. Then we will get total actual summation. Okay. So these 2 factorial, 2 factorial, 3 factorial, 3 factorial, 4 factorial, this 4 factorial. This n factorial, this n factorial, this. So what are left with us? This and this. One is n minus n plus 1 factorial and minus 1. That's why the summation is nothing but n plus 1 factorial minus 1. Okay. I hope you people understood. So this is one thing. Yeah. Now listen all of you. What is permutation and what is combination? What is permutation? And combination. What is the meaning? Mathematical meaning I want. So permutation means arrangement of things. Combination means selection of things. How many different ways you can arrange given things says permutation. How many different ways you can select the things says combination. Okay students. Through one example I will explain this concept. Listen. Yeah student, I have 10 books of all of the same size. Assume that these all are books. I have 10 books. Students listen. I have 10 books all are the same size. Okay. Now I have a shelf. I want to arrange all these books into this shelf. I have 10 books. I want to arrange these 10 books in the shelf. But the capacity of the shelf is only 6 books. What should I do now? From these 10, I want to select some 6 books. From these 10, I want to choose 6 books. After selecting the books, I will arrange the books in any manner that I wish. For example, first maths book, next maths 2, maths 3, physics, chemistry, like that. That order I can arrange. That is my wish. What is the meaning of that? I have 10 books. I want to arrange in a shelf, but the capacity of the shelf is 6. What should do? First thing, we need to select 6 from 10. After selecting, those 6 books should be arranged in the shelf in any manner. Arranged. So here 2 important words are used. Nana. One is selection of books and arrangement of books. Selection of things and arrangement of things. Selection means choosing of things. Arrangements, permuting the things. So what happened? From 10 I want to choose 6. Mathematically that is written as 10C6 in mathematical language. In mathematical language 10 books are given, all are distinct. We want to choose 6 out of them. How many ways you can choose says the symbol 10C6. 10C6 means from 10 we choose 6 books. Nana. Okay. After that, after choosing 6 books, you want to arrange all those 6 books in the shelf. How many different ways arrange says another type of technique that is called permutation. Selection of things and permutation of things. What happened? From 10 books, selecting 6 symbolically, you can write as 10C6. Okay. For example, we want to arrange all the 6 books in a shelf. How many ways you can arrange says permutation 6P6. Notation 6P6. All the 6 should be arranged in a shelf. So what is the meaning of this? From 10 books, 6 books are selected. So what permutation says, what combination says? Permutation says how many ways you can arrange the things. That is says permutation. What combination says? So combination says how many ways you can select the things. How many ways you can group the things. Okay. I hope you people understood meaning of permutation and combination. Listen students. For example, I have 3 objects. Okay, I want choose only 2 from this. I want choose selection. I want select 2 only. AB1 selection, AC1 selection, BC1 selection, completed. Only 3 selections. From A comma B comma C, I want select 2. How many different ways you can select means I can say only 3 selections. One is AB selection, AC selection, BC selection. Just like they are persons. I want to make a group of 2. AB is one group. No, I can't say that BA is another group. AB group and BA group both are same. Understood? So what happened here? I can select only 3 ways. So that is symbolic 3C2. What the value means I can say this is 3. How we will get that we will discuss later. 3C2 means 3. What is the meaning of 3C2? From 3 selection of 2. The value is 3. Okay. Okay, student. From 3 I want select 1. From 3 I want select 1. A, B, C. That is 3C1. That is also 3 only. From 3 I want select 3. From 3 I want select 3. I want to make a group of 3 from 3. Only one group I will make. That is ABC. Only one. That is 3C3 value is 1. One thing. Next thing is, listen students. Next thing is, listen here only. 3 things are given. 3 persons are there. A, B, C persons. I want arrange these 3 persons in a row. So that taking 2 at a time. So there are 2 chairs, Nana. I want allot the places for these 3 persons. How many different ways I can allot? This is say chair 1 and there is a chair 2. First A can sit here, B can sit here, or B can sit here and A can sit here. What happened? A, B and B are different in permutations. Here A, B and B are both are same in combinations. Grouping, A, B group, B, A group, both are same. But here arranging, no, we are arranging the seating arrangement. A can take first chair 1, B can take chair 2, or second time B can take chair 1 and A can take chair 2. Means what is the meaning of this? AB arrangement and B arrangement are different. Here AB selection, BA selection are same. Okay, here order important, here order is not important. Yeah, AB, BA, next AC, CA, BC, CB. How many different ways you can arrange means I can say 1, 2, 3, 4, 5, 6 ways I can arrange. This symbolic written as 3P2, the value 6. 3P2 value 6. From 3 selecting 2, after selecting arranging. Both are there here, selection and arrangements. From 3 things are given. I want arrange 2 at a time in a row. Row is important. In a row. Just like 2 chairs are arranged in a row. I want accommodate these 3 persons in these 2 chairs. How many different ways I can accommodate means I can say that 6 different ways I can accommodate. Okay. Only one chair is given. How many ways you can arrange means I can say 3 ways I can arrange. The chair 1, A can take, B can take, C can take. No? That is 3P1. 3P1 value is 3. Now interesting thing, 3 chairs are there. A very interesting situation now. C1, C2, 3. Chair 1, chair 2, chair 3. 3 persons are there. How many different ways you can arrange them? How many different ways we can accommodate them? So important thing is the chairs are arranged in a row. That is important. The chairs are arranged in a row. Okay. So what happened? First chair I can give for A, next for B, next for C. This is one arrangement. A, C, B. Another possible arrangement. B, A, C. One of the possible arrangement. B, C, A. Another possible arrangement. C, A, B. C, B, A. So what happened here? Totally 1, 2, 3, 4, 5, 6 different ways I can arrange. So that is symbolic as 3P3 equal to 6. Okay, how we will get? For example, 100 persons are given. We want to arrange 10 persons in a row. So that is symbolic as 10P, 100P, 10 only. How to find its value? That is different task. That is different one. So here simple problem. A, B, 3 persons are there. You can write and you can count. But if 100 persons are given, we want to arrange these 100 persons in a 10 chairs which are arranged in a row. How many different ways you can arrange? That is very difficult task. How you can find answer? By using some formula, you can get the solution for this. Okay students, similarly 100% are there. I want to choose 10 of them. How many ways I can choose means 10 C 10 I can say now in this stage, but what is the numerical value of this I can't say now. 10 C 10 ways you can select. I can 10 C 10 100 C 10 ways you can select, means what is the meaning of that? We want 10% from 100. How many different ways you can select? How many different groups you can get? Means I can say that 100 C 10 groups you can create, but what is its simplified form I can't say now. Okay, by using formula you can find out. Okay students, so what is main thing is here, there are two types of techniques here. One is permutations and another is combinations. Permutation means arrangement of things, Nana. Combination means selection of things or groupings of things. Okay, so first of all you want complete concept of permutations. After that only we can start combinations. Okay, permutations. What is the meaning of permutations? Just now explain. Permutations means arrangement of things or arrangement of objects. There are two types of permutations in general in our syllabus. There are two types of permutations. Nana, linear permutations and circular permutations. Totally different these two are. Linear permutations and circular permutations. Linear permutation means arrangement of things in a row. These are chairs. We want to arrange some persons. So arrangement of things in a row. So no, arrangement of things around the circle. Some, this is circular table, some persons are there, 10 persons are there. How many different ways can accommodate them? How can get the answer? That is from circular permutation. This problem belongs to circular permutations. So here what happened? 10 persons are there. We want to arrange them in a row. Means the chairs are arranged in a row. Here chairs are arranged in a circular manner. So what is the difference here? In this arrangement I can identify first place and last place. Here I can't identify which one is first place and which is last place. This can be taken as first, this can be taken as last, or this can be taken as first, this can be taken as last. That's why here identification of first place and last place not possible in circular permutations. In linear permutation, first place and second place you can identify. There are two types of permutations: linear permutations and circular permutation. Arrangement of object in a row is called linear permutation. Arrangement of things around the circle is called circular permutations. What type of problems we will get here? That is important thing. There are 10 persons. Listen all of you. There are 10 persons. We want to arrange these 10%, or we want to accommodate 10 chairs to these 10 persons which are arranged in a row, number by chair 1, chair 2, so on. Okay. How many ways? Says permutation, linear permutation. In that the two particular persons want to sit together. How many different ways you can arrange? This is linear permutations. What circular permutation is saying? There are 10 persons. There are 10 chains which are arranged in a circle. How many different ways you can accommodate them? Says circular permutations. Okay, Nana? So first of all I want complete linear permutations. After that I will start circular permutations. Listen all of you. Here the definition of permutation. A permutation is an arrangement in a definite order of number of objects taken some or all at a time. For example, 10 objects are given. You want to choose 6. After choosing 6, you can arrange 6. In what manner? You can arrange those 6 in a row or around the circle. Okay. So arrangement of objects is known as permutations. Selecting 6 or 10. What that is meaning? A permutation is an arrangement in a definite order of number of objects taken some or all at a time. That is important thing. Okay. Now just now explained there are two types of permutations, linear and circular permutations. In linear permutation refers to the number of ordered arrangements of objects in a line. That is important. In a line, objects should be arranged in a line. But important note, student, important note. this is the arrangement of objects in a row. For example, these are the chairs. This is chair 1, this chair 2, chair 3, that, like that. This type of arrangement is taken as linear permutations. For example, you want to arrange the things around the circle, such permutation is known as circular permutation. But if your table is in this shape, semicircular shape, so this is chair 1, chair 2, chair 3, chair 4, chair 5, chair 6, like that. We want to arrange things. What should I take this? Either linear or circular. That is important. So this is treated as linear permutation. This is taken as linear permutation because I can identify first place and last place, or first chair and second chair position I can identify here. That's why if your table is in this shape, the arrangement also treated as linear permutations. In just arranging the object in a row. That is the meaning here. Here circular permutation. Okay, students. Okay, listen now here. Permutations when all objects are distinct. This is one case. Permutations when all objects are distinct. For example, by using A, B, C, how many arrangements can make taking two at a time? That is one thing. No? For example, A, B given. We want choose two at a time. We want to arrange in a row, or you want choose three at a time from this 1, 2, 3, 4, 6 arrangements. We want to arrange in a row. That is different because all are not different. No, A, B, C, B. All are not different. That is second case. What is the first case here? Permutations when all objects are distinct, means different. So here one theorem is given. Observe this theorem. I will explain this theorem now. The number of permutations of n distinct objects taken are at a time when 0 less than or equal to n, and the object do not repeat is n into n minus 1 into n minus 2 and so on, n minus r plus 1, which is denoted by NPR. So what this theorem is saying, that I will explain now. NPR value is equal to n into n minus 1 and so on, n minus r plus 1. This is the meaning of the theorem. What is the actual meaning of the theorem is, there are n objects. We want choose r objects from n. After choosing r, we want arrange in a row. How many different ways you can arrange? That says NPR. That says NPR. What says NPR? What is the NPR value? N into n minus 1 into n minus 2 so on, n minus r plus 1 ways. This says this theorem. Okay, but how to prove? That is interesting thing. Listen, student. The number of permutations is linear permutations here. That is important thing. The number of permutations of n distinct objects taken are at a time, and the objects do not repeat. Objects are not repeating. All are distinct. All are distinct. And the number of arrangement without repetition, so is denoted by NPR, and its value equal to n into n minus 1 into so on, n minus r plus 1. Okay, now I will prove this now. What this theorem saying, that we have n distinct objects now. 1, 2, 3, so on. N distinct objects have. We want to arrange all these objects in a row. You can arrange. You can choose all or some. For example, you want to choose some means r from n. We want to choose n r elements from this n. All are different, and these r elements should be arranged in a row. How many different ways you can arrange a row says NPR. What is the NPR value? N into n minus 1 so on, n minus r plus 1 ways we can arrange. That says theorem. So not yet proved. Just accept it. N distinct objects are given. From n distinct objects you want to choose r and arrange in a row. So here also repetition won't allowed. What is the meaning of that? 1, 2, 3 given. I want to make a 2-digit number. So 1, 2, 1, 3, 2, 3, 2, 1, 3, 1, 3, 2. What happened? No, repetition won't allow. Repetition won't allow. You in this number, 1 used only once, 2 also used only once. For example, 2, 2. These are 2-digit number only. So what happened here? Repetition allowed. Here in this first case, repetition not allowed. If repetition not allowed, how many different ways you can arrange means you can say that NPR ways you can arrange. I will prove NPR equal to n into n minus 1 into n minus 2 so on, n minus r plus 1. What is the meaning of this means? N from n distinct objects selecting R, after selecting R, those R elements should be arranged in a row. How many different ways you can arrange? Says NPR. Okay. So listen students, through example I will explain the concept. 1, 2, 3, 4 given Nana. By using these four, from these four numbers, I want choose to, I want arrange in a row. See, 2, 3, one arrangement in a row. No, I arranged it. That is 2, 3. So I will write it neatly. Wait, students, listen. First of one of the arrangement 1, 2, 1, 3, 1, 4, 2, 3. Okay, 2, 4, 3, 4, 2, 1, 3, 1, 4, 1, 3, 2, 4, 2, 4, 3. What happened? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Use formula. Use formula. N equal to 4, R equal to 2. N equal to 4, R equal to 2. Substitute in that formula, Nana. Using formula, actually we got 12, no? By using formulas, I will show, we will get 12 only. So 4P2 equal to 4 into 4 minus 1. 4 minus 2, we can't write 4 minus, see this, what is the last one? 4 minus 2 plus 1 is last bracket. 5 minus 2 is last bracket. 3, up to 3 only, means 4 into 3 only, that is 12 only. Okay students, so what is the meaning of this? So selecting 2 from this 4, after selecting 2, arranging in a row is nothing but 12. This is same as, this is same as, just like filling all these 4 elements into 2 blanks, both are same, no? Selecting 2 from this 4, after selecting 2 from this 4, arranging in a row is same as, filling all these 4 elements into 2 blanks when repetition not allowed. Same meaning, no? 1, 2, 2, 1, 3, 2. Okay. So here also students, NPR, actual, what is the actual meaning of NPR? From n distinct elements, choosing R, after choosing R, arranging in a row, that is NPR. That is same as filling all these n distinct elements into R blanks. In my previous example, 1, 2, 3, 4 taken and 2 blanks are taken because I want to make a arrangement of 2 at a time. So here n distinct elements are given, I want to arrange R at a time. So that is NPR only, no? What is the meaning of that? What is NPR is same as filling all those n distinct elements into these R blanks when repetition is not allowed. Both are same. Okay. So I can show. For example, these are the R blanks. So that is not right. Wait. This is first blank. This is second blank. Third blank. Fourth blank. R minus 1th blank. Rth blank. Now I want to fill with the n distinct elements. First blank I want to fill. How many ways? First blank I can fill. N ways I can fill first blank. Using any n I can fill. Now this one. N ways I can fill first blank. Second blank I want to fill. Second blank. From n elements, any one of the element is used up here. So we have with us n minus 1 left. With us n minus 1 elements left. By using those n minus 1 left, I can by using those n minus 1 elements, I can fill this blank. Means second blank can fill in n minus 1 ways. These two boxes successively you can fill by using product rule, that is n into n minus 1 ways. Okay, that is latter case. Leave it. Third blank can be filled. Actually, we have n elements. Here one is used up. Here also one used up. With us now n minus 2. Now by using this n minus 2, I can fill the third blank in n minus 2 ways. N minus 2 ways. I can write n minus 2 ways. Fourth blank, n minus 3 ways. So observe now. What happened here? N. Here n minus of 2 minus 1. Here n minus of 3 minus 1. N minus of 4 minus 1 ways. So on. Rth blank. How many ways you can fill? N minus of R minus 1 ways you can fill. All these R blanks successfully you can fill by using product rule. N into this one. N minus 1 into this one. N minus 2 into so on. Last. What is that? N minus R plus 1 ways. So from product rule you can fill all those n elements in these n blanks in how many ways? Means I can say n into n minus 1 into n minus 2 and so on, n minus r plus 1 ways. So hence the theorem. Okay, final conclusion, Nana. Final conclusion, listen. Therefore NPR is nothing but n into n minus 1 into n minus 2 and so on, n minus r plus 1. That's all. You need to remember this. Okay.